I want to talk to you about standard deviation conceptually so that you understand what it is. Because in all educational research, actually in all research, when you report the mean of a group of numbers or scores, you also report the standard deviation, and you need to understand what that is. So let's say I gave a test and these were the scores that the students got. So let's look at what we can find out from those numbers. First of all, the most obvious thing is, what is the average or the mean of those numbers? And you know how to figure that out, and it turns out it's 16.1. Well, where do those scores fall on a number line? Are they bunched together? Are they really far apart? Well, one thing we ask is the range. So in these numbers, the low is 12 and the high is 20. So on a number line, there's its range. Those scores from my test fall right in there. Well, how far from the average is each score? Like, are they all bunched together or are they spread apart? Think about that. Bunched together, spread apart. There's the mean, and there are the data points. And you can see that they're spread apart, clear across that range. When we look at the average distance that the data points are from the mean, that's called the standard deviation, and those are the symbols for it. So you can think of it as how, on average, how far from the mean are those data points. So let's take a look at how that's figured out. Don't worry about the math. Okay, this data point here is 3.1 points below the mean. And this data point, these two data points here are 1.9 points above the mean. We can do that for each and every one of the data points. Every one of them has a distance from the mean. And that's what we want to look at for the standard deviation. And so we use this formula, which is not that complicated. It's a lot like the formula for an average. And we find out for this group of scores, if we were to plug all those numbers in there, that the mean is 16.1 and the standard deviation, that average distance from the mean, is 3.04. Standard deviation doesn't mean anything without, it's meaningless without the average. And the average is meaningless without the standard deviation. They always go together. So let's compare one. So this is the one we've been working with, where the mean is 16.1 and the standard deviation is 3.04. Let's look at another group of numbers. Once again, the mean is 16.1. But how are they bunched along that number line? The range is the same. The low is 12 and the high is 20. There's the mean. And there's where the data points fall. Compare those two sets of data points. They're differently dispersed along the number line, aren't they? They seem to be more bunched towards the middle. So the average distance from the mean is probably not going to be as big as it is on the example below. And it turns out that the standard deviation for that group of numbers is 2.23. They are closer together, especially here in the middle area. So let's summarize this. Standard deviation, and there's the symbol that we use when it's for the population, and we use an S when it's for the sample. It tells you conceptually the average distance that all the data points are from the mean. It's in the same units as the mean is. So in this first example, the mean of a group of numbers is 73.2, and the standard deviation for them is 12.1 points. In the middle one, again, the mean is the same, 73.2. But in this case, the standard deviation is only 6.3 points. So the points are bunched much closer together, aren't they? And then in the last example, same mean, but look at the spread on this one. The standard deviation for this one is 23.4 points. So there's 23.4 points on average between the data points and the mean. So they're really spread out much further from the mean, aren't they? And that's all there is to standard deviation.